Fog, high five if it's time for CMA Math Academy. Let's get started the way we always do. We've got our learning goals. So what are we going to be learning today? Students will solve equations with variables on both sides using inverse operations. All right, that's what we went over yesterday in our vocabulary, and now we're just going to put that to practice. Why are we doing this? Well, we already know how to solve two-step equations. We will build on that to solve multi-step equations, which is what we'll be doing today. How will you know when you've been successful? When you are given an equation with variables on both sides, students will be able to simplify and solve using inverse operations. Go ahead and turn to page M313. Hopefully you tore out this section earlier today, and now we're going to start here on page 13. We are going to be skipping around a little bit, and then you're going to be coming back to finish some of these equations, but we are all of our problems are going to be from this page. So this is the only page you need is M313. Hopefully you've had a chance to get there. Now, I'm going to skip question 1. You're going to come back at the end and solve that. We're going to go ahead and skip to 2, and I'm going to do 2, 3, and 4. We're going to kind of do that together on the video, and then you're going to have a chance to do 1 and 5, and then there'll be another little practice sheet that you're going to get and solve. Okay, so if we look at 2, let's just start out with the basics. So looking at 2, we can tell we've got an x on both sides. So we have variable. It's the same variable, but we have variables on both sides of the equation. Okay? But let's start with the basics. So looking at that equation, I want you to first think about it, and then you're going to share with your table here in 1 second. Okay? How many terms are there in that equation? Just the number of terms. That's all we're looking for here. Okay? Hopefully you have an answer. I want person number 1 in your group to start, and then everyone else is going to go around and say if they agree. If they don't agree, tell them why. Person number 1, go ahead. All right, hopefully you guys came up with the answer 4. We have a negative 12 and 11/100 x, and its like term on the other side of the equation is negative 3.5 x. Okay, so I'm going to circle those because they're the same, they're like terms. And then we have, I'm going to box these in, we have 1 constant on this side and 1 constant on this side. Okay, so we've got 1, 2, 3, 4 terms. Okay, our goal is to solve x, and we know we need to use inverse operations. Okay, so the first thing that I'm going to do on this one is combine my x terms. Okay, my variables. I just want one variable term. Now, if these were positive numbers on both sides, then I would probably start by subtracting the 3.5. But since they're negative, I'm actually going to go ahead and deal with the 12 and 11/100 and get rid of that, because if I move that to the other side, I'm going to end up with a positive number on the other side. Okay, so I'm going to do this as my first step. So my inverse operation here is going to be to add 12 and 11/100 x to both sides. So when I do this, on this side, I have a positive and a negative of the same thing, so those just cancel out. So all I have left is a negative 10.5. This answer just, or this number, sorry, this constant just comes down here. And now I have to figure out, okay, I have a negative 3.5, a positive 12 and 11/100ths. What is the difference between those? Because I have a positive and a negative, so I don't want to add. I actually want to subtract, and I get a difference of 8 and 61/100ths x. And it's a positive because I had, my positive number was larger than my negative number. Okay? All right, so now that I have that, it's pretty simple, right? All I need to do is isolate my x. Now we just have a basic two-step equation. So my first step, my inverse operation of addition is subtraction. So I'm going to subtract that 75 and 6/10 on both sides. And since they're both negative numbers, I'm going to add and keep the sign. Whoop. And I'm going to get negative 86 and 1/10. And on this side, all I have left is 8 and 61/100ths x. Okay, so that was one inverse operation. Now I need to find out what 1x is. So I need to do the inverse of multiplication, which is division by 8 and 61/100ths. Well, this over here is just going to become x. And over here, if I'm taking 86 and 1/10 divided by 8 and 61/100ths, well, really that's just, that'll go in there 10 times, so I know it's negative 10. So now I have negative 10 equals x. I have my answer for x. That's what we were looking for this whole time. So circle my answer. And we're done with the first problem. Okay. So once we made it to the second step, once we made it to right here, everything below this we've done before. You know how to do this. This is just a two-step equation. It was really just combining our terms. Up here, this was the new stuff. But once we took care of that and combined our x terms, our variables, then we could solve really easy. Okay? Now some of them are going to take a little bit more than one step to combine, so our new stuff is going to take a little bit longer. But for the most part, you're just going to do a step or two, and then it's just a two-step equation to solve. So now we're going to go ahead and go to question number 3. Okay, question number 3. Now, in question number 3, just look at the left side for a second. We've got 10x plus 2, but that's all over the number 2. Okay, we've got a couple different options. Okay? If we want to just get rid of this 2, we can take the whole thing and multiply it by 2 and cancel out the 2 that we're dividing by. Or I can split this up to 10x divided by 2 plus 2 divided by 2, which is what we did when we were converting standard form to slope-intercept form. We had to do this where we would divide both terms by the same number. Okay? It doesn't matter which way I do it. I'm going to get the same answer at the end. But just for the sake of this problem, I'm going to go ahead and instead start by taking the whole thing times 2. Okay? Because when I take 10x plus 2 times 2 and then turn around and divide the whole thing by 2, I'm really just canceling this 2 and this 2. And all I have is 10x plus 2. And if I do that on one side, I have to do it to the other. So I have to take this all times 2. this is just the distributive property. 2 times 4 is 8x. 2 times 1 is 2. Divided by 4 is 1/2, so plus 1/2. Okay. So that was one step, but we're still not quite there to solve because we have x's on both sides. We've got that variable on the both sides. Now here is where, when you get to this step, you want to find your term that is the smallest. So we have 10x and we have 8x. Well, obviously 8x is less than 10x. So that's the one that I'm going to subtract. So I am going to take away 8x from both sides. Well, over here, these cancel. So all I am left with is 1/2. The 2 is going to just come down. And now 10 minus 8 is 2x. So now I have 2x plus 2 equals 1/2. Okay. Now here, again, this is kind of the cutoff. I just did all of that. This was new stuff. This is just manipulating the equation to get the variable all by itself. And now I just solve using our normal two-step equation method, which is inverse operation. So my first step will be to subtract 2, because subtracting is the opposite of addition. So if I subtract 2 from both sides, now I have 2x equals negative, because I'm subtracting 2. I'm really taking a half away and making the answer negative, so I have negative 1 1/2. Now, I need to find what 1x is, not 2x, so I need to divide by 2. Divide by 2. Now we have just 1x equals. So if I take 1/2 and divide it by 2, well, 1/2, this is the same thing as negative 3/2 divided by 2, which is the same thing as negative 3/2 times 1/2, and I get negative 3/4. So my answer is negative 3/4. And that's my answer. Again, 2 steps of new things to get it down to an equation that we are all comfortable solving. All right, I'm going to do question number 4 with you. But before I start on this one, when you're looking at that, this should kind of maybe remind you of a spiral math question that we do almost every single week. And what do we do when we have a fraction outside of a parentheses? What do we do? I want you to think about that. And again, I want you to talk with your group. This time person number 2 is going to start the discussion. And you're going to tell the rest of your group, what do we do with that 3/8 and that 1/2 that are outside the parentheses? I'll give you 20 seconds to talk with your group. Person number 2, ready, go. All right, so hopefully somebody in your group came up with the distributive property. So we would take this 3/8 times x, 3/8 times 8, and the same thing is true over here with 1/2 to the x and the 5. Okay, so let's just go ahead and do that to start with. So when we take 3/8 times x, we get 3/8 x. And then when we take 3/8 times 8, it's really saying 3 times 8, which is 24. 24 divided by 8 is 3, so plus 3. And then over here, 1/2 times x is 1/2 x. And 1/2 times 5 is 5 over 2, and I'm just going to leave it like that, plus 1/4. Okay. So we've got a lot of fractions here, but let's not freak out. We can still solve everything the same way. So we've got some constants over here on this side, on the right side, and a constant on the left side. The first thing I'm going to do is combine our constants on the right. So we still have just 3/8 x plus 3 on this side. Over here we still have 1/2 x. But now I'm going to add 1/4 and 5/2. So I would do this first, 5/2 plus 2. I was going to multiply the other one. I want to multiply this one by 2 and get 10 over 4 plus 1 over 4. That's what I want to do. So now I have 11/4 on this side. So this is plus 11/4. All right, so now I have a variable and a constant on both sides. So I need to combine my terms using inverse operations. So I've got 3/8 and I've got 1/2. Well, 3/8 is a little bit less than 1/2. So I'm going to subtract 3/8 x from both sides. So when I do that, again, I have to take my 1/2 times 4, so I would get 4/8 minus 3/8, which equals 1/8. So I have 1/8 x on this side. I have no more x's, no more variables left on this side, and I just have a 3 equals 1/8 x plus 11/4. All right, now I need to get this 11/4 to the other side. So I need to subtract 11/4 from both sides. So I have 3 minus 11/4. Well, 3 is the same thing as 3 over 1. And 3 over 1 times 4 gives me 12 over 4 minus 11 over 4. And I end up with 1/4. So I have 1/4 equals 1/8 x. And I'm almost done, except that I need not 1/8 x, but I need 1x. Okay? Well, 1/8 is the coefficient of x. So if I want to get x by itself, if that was just a 8 instead of a 1/8, I would divide by 8. But since it's 1/8, if I divide by 1/8, I'm really multiplying by 8 over 1. So that's all I really need to do is multiply by 8 on both sides. So on the right side, I just have x, because the 8's cancel out, and I'm left with x. And over here, I have 8 times 1, which is 8. 8 divided by 4 is 2, so x equals 2. Okay. Now that one was a long process. We did the distributive property twice. We had to add some fractions. Then we combined like terms using inverse operations to get our 3/8 to the other side. And then we solved just a 2-step equation. There were just fractions involved. Okay, but nothing we can't do. Just take your time. Okay, work slow. Go 1 step at a time. And you'll be able to do it. Okay. So what I'm going to do now is give you a little bit of time to answer number 1 and number 4 using, or sorry, number 5. We already did number 4. Number 5. So use 2, 3, and 4 as a reference for you, okay, to solve 1 and 5. In a little bit, I'm going to come back. We're going to check, and then we'll get you your last thing that we're going to do today, which is just a couple problems to practice this. Okay. So I'm going to give you some time now.